Okay. So before I start, I think today's lecture will go over by like 15 minutes. Okay, so 12:15, then we will end. If you have to go, you go. Okay, as always, it's in recording. Okay, so now we calculate what is the stress orientation when the element is rotated 30 degrees from the horizontal axis, 30 degrees anti-clockwise. Okay, so we found our shear, our y30, our stress x30. Okay, so now we have to bring it back to the element again. Okay, so let me copy this so you can see this. Right. So this is at 0, 0, 0, 0, I mean 0 degrees element rotation. So now we are going to rotate the element by 30 degrees. Okay, so this is our 0. Right. So we're going to rotate by 30 degrees. So I'm going to put this as 30. Where is my cursor? 30 degrees anti-clockwise. Okay. Right. So this is our axis. Okay. So this is our 30 degrees. Okay. So we again we are going to sketch out where is our y. Okay. So this is our y, and over here this is our x, right? So this will become our y30, right? Our y30. So we calculated, so the normal stress are always the easy one, right? So if you look at the values, the y30, wait, hold on. Right, we'll have a compression of minus 22.296 megapascal. And then the x30, right, will be in tension, and it will go by 42.296. Okay. It's the shear, it's not difficult, okay? It's a bit, you have to look at how your element will rotate. Okay, let's look at y30 first. Okay, so I'm going to highlight y30. Okay, this regarding the shear. We know the shear is 42.296. We know that. Okay, we know. Okay, sorry, the shear is 16.032. Okay, we know that the shear is 16.032. So now, if you look at y30, the element has to rotate which direction? Anyone? What direction is this?
Counterclockwise.
Anti-clockwise, right? So for the element at y30 to do anti-clockwise, the arrow has to go this way or the top one or the bottom one relative to the element.
The bottom one.
Yep, the bottom one. Okay, so there is one side. Then if you look at x30, you look at x30, the element has to rotate what? In the clockwise direction, right? So for the element to rotate from x30 to rotate in the clockwise direction, it has to go and come down here. So this is how you draw it. And this is what we call 16.032 megapascal. And this is it positive shear or negative shear? Anyone?
Negative.
Yep. So this is negative shear. You don't need to put that by showing your arrow, people will know that is what? negative shear. Okay, so this is how, right? Given a 30 degrees angle, I mean, you can use the equation of transformation. Forget it. Look at the math down here. The math is so easy, right? I did not do any complex math down here at all. Okay, yes. Someone has a question, or we're okay?
Professor?
Yes.
What does the 30 degree, what does that mean? Is it on the 30 degree plane?
So 30 degrees is to let the element rotate by 30 degrees. What is the stress state?
Okay.
For example, okay, I'll give you an example. Now you have a structure. You have a structure like this, right? Right. You have a structure there. This is where your element is. Okay, this is where the element is. Then your wood grain is orientated at 30 degrees. These are your wood grains. Okay, wood grains or carbon fiber orientation. Right? And then you ask to calculate, hey, what is the stress state of our carbon fiber or wood grains, the grains of our wood? Okay, what are the stresses? Because it's always failing over there. There you go. This is how you calculate. Okay, so this is one sort of application you can do, but this is not enough. This is just a foundation. In real world, you always use 3D Mohr Circle. I repeat again, this is just a foundation. This is just a foundation. Sometimes 2D Mohr Circle can be used to analyze a 3D structure, okay, but sometimes it cannot. So graduate from McMaster must be capable of doing 3D Mohr Circle. Why? Because in situation where you only use 2D Mohr Circle, your structure will fail. Okay, so that's why I take it upon myself that I need you guys to learn what 3D Mohr Circle. A lot of times this course, okay, we start at 2D Mohr Circle, watch our hand, let's go. No, 3D Mohr Circle is as important. Okay, so let's go for 3D Mohr Circle.
Sir, sorry to ask this again, but could you please just explain the shear with the counterclockwise and clockwise angle again?
No, don't be sorry about it. Okay, I think so. If you look at Y30, right, which is the Y30 over here. So this is our Y30, right? Y30 is over here, right? It corresponds to a rotation where it's clockwise or anti-clockwise.
Where it's anti-clockwise.
So for Y30 to be anti-clockwise, this arrow has to come down. Yes or no?
Yes.
For the element to rotate what? In an anti-clockwise direction. If you look at X30 now, right? X30 rotation is in a what? Clockwise direction. Yes?
Yes.
So if you look at X30, for it to be rotated in a clockwise direction, the arrow has to come down. Yes or no?
Yeah.
There you go.
Oh, got it. Thank you.
Okay. Now we are going for 3D Mohr Circle. Okay, and then we're going to do one example of 3D Mohr Circle. Now the 3D Mohr Circle example we're going to do is we're going to combine elastic behavior, okay, elastic behavior and 3D Mohr Circle. Now this is the real world now, okay. The basic is still the same, okay. It's only that you have to introduce 2 extra circles, okay. So altogether there are 3 circles. So in 3D now, right, in 3D Mohr Circle, right, so as I say, this is 3D. So this is my X, Y, and Z. Okay, so I'm going to draw 3D. Now it's a cube, not a cube, but a 3D feature. Right? Okay. So now this is my depth. So now our stress state goes like this, okay? So this is stress X, stress Y, stress Z. Okay. So now we have planes now, yes or no? Right? So what we have down here, right? So what we have, this is our This is our YZ plane. This is our XZ plane. And over here, this is our XY plane. So in terms of shear, so if we draw shear in this way, right, shear in this, so this is shear intersecting plane X, the shear stress direction is Y, right? Right. Then I'll use a different color. Then we have shear in this direction also. Right, that's our shear. So this shear, the intersecting plane is in the X direction. The shear stress is in Z direction. Okay. And then we have another shear, which is in this direction. Right. So for this case, we have shear, the intersecting plane is Z and then Y. Okay. So we have 6 stresses. Okay. Right. I'm going to teach you what is in plane on our plane. Okay. So this plane over here, XY plane, is our in plane. And then the other plane, this is our out of plane. And the exact plane, this is also our out of plane. Can anyone tell me why? Because I tried reading the textbook, they never tell me why. Can anyone tell me why XY plane is in plane, YZ plane is out of plane? Anyway. Hello?
Professor?
Yes.
Shouldn't it be tau's YZ for the direction going up?
Which one?
Instead of tau ZY, shouldn't it be tau YZ?
This one?
Yeah.
The shear stress is in Y direction or Z direction?
It's in Y direction.
There you go. Right? So this is the direction of the shear. Right?
Okay.
Okay. So now, can anyone tell me why? How do we know what's in plane or out of plane? Anyone, please. Okay, I'll give you another example. No one is answering it. I will give you another example.
In plane is the surface we're looking at.
All surface we are looking at. I like that. Okay, now if I draw the orientation this way, this is my in plane, and this is the out of plane. Now, can anyone tell me what is in plane and out of plane? It's not difficult. Anyone? Think simple,
Picture
please.
surface area.
Yeah?
The surface area?
Yes. Okay. The largest surface area is the in plane. I try reading the book, they don't tell me. Okay, so the largest area is the in plane. Okay, this is what we call pattern recognition. Okay, this is what we call pattern recognition. Okay, so I try reading the textbook to explain to me what is in plane, out plane. They don't say anything. Okay, it's so called, it is known. Rubbish is not, it is known. Okay, it's not so obvious. Okay, so again, okay, so later on when we ask you to calculate the in plane, out of plane, or in 2D Mohr circle, in the examples that or the homework, they say this is the in plane, out of plane, out of plane. You're like, what is this shit going on with the in plane and out of plane? Okay, so again, the 3D Mohr circle, the 3D Mohr circle. Okay, 3D Mohr circle is based on, or is to determine principal stress